Okay, analyzing line to fit 4.5 part 2.
Very good. Nope, you're good. Just leave it. Thank you.
She said, I don't want to hear my voice
All right, so yesterday, or 2 days ago, we practiced drawing in those lines of fit. Okay, you guys have done some by hand, then you've done some using the calculator to get a perfect line of fit. Okay, well, what we can do is, like, let's go back to that example where I drew in this line of fit. What I could do now with this line of fit is use it to make a prediction. Okay, do I have any ages of cars in that table that were 2 years old? No. I had a car that was a year old. I had a car that was 3 years old. But what I could do is use my line to make a prediction. If I had a car that was 2 years old, what would the price be? So it might be a little more than $19,000. That's not a point in the table, but what I just did is I made a prediction using that line. So there's a name for that. Okay, and let's go back like this. The type of prediction that I just did was called an interpolation.
So guys, that first blank on the back side, you're going to write interpolation.
Yeah.
So what I did is I used a value that I knew from the table, another value that I knew,
I replaced you.
okay, and I made a prediction between the two.
Yes,
Okay. So any question on that idea? All right. So again, here's some other data points. Let's say those were all points in your table. Here's a line. And let's say you make a prediction about that point right there. What you just did is you predicted between two other dots. Now, let's say I make a prediction up here. Do I have any red dots that go up that high? Nope. No. So now what I'm doing is I'm not predicting between two red dots. I'm predicting past them all. Okay? That's also a prediction, but that's called extrapolating. Extrapolation. You're still making a prediction, but you're predicting beyond all the numbers.
Like we did before, we had the 1 and the 3. We didn't have 2. That's between two things. So like inter, right? That's why it's called interpolation. Extrapolation is like outside those numbers. You can still use the numbers to help you, but it's not going to be between 2 points anymore. It's going to be outside of them.
So interpolation, approximate between. Extrapolation, predict outside. You're predicting beyond. Okay, and a lot of times that's what they do with like the weather. Right? They have computers that try to extrapolate what the weather's going to be tomorrow. They try to predict it based on past weather that's happened. They're just making a prediction. Is the prediction always accurate?
No.
No. When you extrapolate, that's kind of risky. We don't know if it's going to work, if it's going to not work. Just like the weather. Sometimes they predict right, sometimes they predict wrong. So any questions on those two words? Interpolation, extrapolation.
I think there's one more piece on this one, Hager.
All right. Oh yeah. So in general, the farther removed you try to predict, like let's say you try to predict the weather tomorrow, and then you try to predict the weather a week from now. Which one are you probably going to be more accurate with? Tomorrow, because it's closer. It's not farther away. The farther away you try to make a prediction, the less accurate, the less confidence you can have. Just like if you try to predict the weather a week from now, you can't really be that confident. Okay? But tomorrow, you can probably be a little more confident. That's what that's saying. Any question on that idea? Okay. All right, so there's a problem in the book about Old Faithful. That's a geyser. Kind of, people know what that is?
Yes.
Yeah, just erupts regularly.
Water shoot out of the ground.
Yep, very hot water. And you can't predict exactly when it's going to erupt. But a lot of people, they have an idea of how often you're going to get an eruption. And a lot of it has to do with the last eruption. If the last eruption was very short, then the next eruption is probably going to be sooner. It's almost like it didn't get rid of all the energy. But if the last eruption lasted a long time, then the next eruption may take a while to happen. But this equation roughly predicts how often it's going to erupt. If you ever actually really go see it, there's a phone number you can call, and they say the next eruption will be in 28 minutes, or something like that. So you can actually call the phone numbers. They don't stand there waiting for 3 hours if it's not going to happen. Right. So in this formula, y is the time until the eruption, and x is how long the previous eruption lasted. Okay, so what we're going to do is we're going to try to make a prediction using this equation. The prediction I want to make, okay, based on this equation, is approximate the eruption duration if the time to the previous eruption is 77 minutes.
So guys, we have an equation set up there, right? That's 77 minutes. What variable is that going to be plugged in for?
Why?
Why do you say y, Samantha? I agree with you.
Oh.
But when you read that sentence, what information that told you was going to be y? Okay. What do you think, Josiah?
It says minutes.
Huh?
Okay.
It says minutes, but again, eruption duration could also be measured in minutes too, right?
Isn't that
Yeah, but it says minutes.
They're both measured in
Well, we
minutes.
measure in minutes. What do you think, Sophia?
Because it says that the Y is a time until eruption.
And what in the sentence? What does it say in the sentence?
Time.
Huh?
Time.
Time to the previous eruption, right? So a time until it's going to happen. All right? So let's make sure if we give you something like this, you're just going to read to make sure you're plugging in for the right information.
And the question says approximate the duration. Duration is x.
We're not giving it to you.
Eruption duration is x. That's what we don't know. So we're going to fill in 77 for y. Okay. Can someone tell me what my equation is going to look like when I do that? X
77 equals 12.0 x plus 35.
plus 35.
So that's the second equation you guys have solved a bunch of times this year.
Okay. So what's my first step to solve for x?
You have to get x by itself, so you have to minus 35.
Yep. I like it. Minus 35. 7 minus 5 gives me 2. 7 minus 3 gives me 42. All right. And now I have one last step.
You have to divide 12.
Divide by 12. Divide by 12.
3. So 3
3, yeah, it's going to be 3 point something.
3 equals x.
Is it exactly 3.5?
Yep.
All right. So
Is that just 12?
so x is 3.5.
So what does that mean, guys?
That X is 3.5.
Okay, but what is x? What is x?
3.5 minutes.
3.5 minutes until the
Oh,
next election.
not until the next eruption.
For how long?
Exactly. It's going to last 3.5 minutes.
What? Duration is the.
How long?
Kind of think of it as like
I didn't think this.
it's like building up energy. So the longer and longer and longer it takes for the eruption, when it finally happens, it's going to last a long time. Okay? Does that make sense?
I just didn't read it.
All right. Now, if the previous eruption was 5 minutes, okay, it lasted 5 minutes, I want to know when the next one is going to be. So what is this?
You're gonna plug in that.
Is that x or y?
X.
X. The previous eruption was 5 minutes. So how long until the next eruption?
So you're gonna put
Until the next eruption.
Y. So Y equals.
Yeah. So y equals
Equals 12.0 times 5.
10. Plus 35. Perfect. Now remember, this isn't exact. So like, if you're actually at the park where Old Faithful is, and you're like, wait, I got this formula and it says it should be erupting right now. Remember, this is like predicting the weather. It's not exact. Maybe it happens, maybe it doesn't. But it'll give you a guideline. Joe? Yep. Yes, 12 times 5 gives you 60.
I did it right.
95 what, Joe?
Minutes.
Minutes.
Yeah, sure, right.
So if the previous eruption lasted 5 minutes, you're not going to see another one till 95 minutes later.
Wait, so
That's a good-
It's what?
How often does it erupt?
Well, it depends how long the previous eruption was. It changes.
No, I mean like in real life.
In real life, it can erupt anywhere between every 60 minutes and maybe 100 minutes.
So it's happening right now.
It happens every day, every 60 to 100 minutes, every day.
Oh my god, what time did it happen today?
I don't know, I didn't look it up.
Can you call?
I don't have the phone number, but yeah, if we have time, I'll call after.
Oh my god, really?
I'll look it up and I'll put it on speakerphone.
Thank you. I want to know when
If we have time, I don't know if we'll have time.
There's a live feed on them too.
You could probably watch it live, yes. Yep.
I don't want to. Y'all know waste my time.
Look up a YouTube.
We're amazed by Old Faithful.
Amazing.
Is that Yellowstone?
I don't like the bro.
I believe
Yeah,
so.
but I don't like. I could Google that stuff. Instead of waiting hours later.
Yeah,
So
but
can we have that description again? How's it called?
Yeah.
All right, so let's look at another one. Okay, I'm going to give you a formula from example 1. I'm not going to make you come up with it.
Oh, so it's the same one.
will it always be the same formula?
No.
They'll give you a formula.
No.
Yep, I'm going to give it to you right now.
So we're just using the same one.
Okay, I actually think
The form is going to be different.
that it's not healthy
It's
because
gonna
my
be
fingers
right now.
are always at home.
I don't like that. I was gonna
It's like I touch your fingers when I have frostbite.
Hi, Grandpa. I haven't talked to
It's like I
you
touch
all
your fingers,
day.
they're always cold.
Okay, so here's your formula.
Guys,
Okay, X is going to represent teachers. Y
Guys or X?
is students.
Or Y?
X is teachers, Y is students.
Can I just do you have a calculator?
and guys, we can use the graphic calculator for this, right?
Yes.
Do we have to?
No.
If you want to do it in your head, that's fine too.
No,
It
you
says-
gotta multiply 20.
How many students would be at a school that has 20 teachers? And remember, this is just a formula that predicts it. It doesn't mean it's going to be exact. Where would the 20 get plugged in?
The X one.
So,
20 is how many teachers?
Yes.
That's good.
That's the X.
Oh, so I did that.
Can somebody tell me what my equation would be?
it's 21 times 20
Yep,
plus 42.
plus 42. Okay. 21 times 20 is going to give me 400.
20, 420.
Oh my god, 420!
Oh!
Easy.
Why?
I forgot you guys aren't that old.
What's
I'm older than you. That's your
what's
So nice.
420 plus 42?
It came out wrong.
It's 462.
462
Oh,
students.
62.
Well, I'm at 462.
Yeah.
Okay, so based on that formula, if this school had 20 teachers, that would mean it might have about 462 students. Okay, roughly. Now, keep in mind, with this kind of formula, if you get a decimal, would a decimal answer really make sense?
No.
No, because we have to round
Like
up.
a 0.5 student.
Yeah, we can't really have half a student.
Well, that we can.
Okay?
Only mentally, not physically.
Yes.
No.
All right, so now, how many teachers would be at a school?
Oh, then we have to plug
Guys,
that for the
guys,
Y.
take-
Wait, I got a decimal.
Guys, take 20 seconds and write it down on your sheet.
Can I answer?
I got a decimal.
Did you write it down?
Did you get a decimal?
Okay.
Did you get a decimal?
No.
Okay, guys, can somebody tell me,
Wait, I'm not
what's the equation?
Oh, can I tell you?
Yes.
Okay, so for the equation, I got 335 equals 21x plus 42.
Does everybody agree with that?
Yes.
Jesus.
I was close.
Okay, now what do we do?
You Subtract 42
Yeah.
on both sides.
Subtract 42. Can somebody tell me what's 335 minus 42? What is it, Joe?
Okay, both times I got a decimal. This doesn't make sense.
Same, I got a decimal.
Can I answer?
I got 14 point blah 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 blah.
And what's my last step?
You have to divide what it gives you. Wait. You didn't subtract correctly, I don't think. Now I'm confused. Did I not?
So, what happens if I get a decimal?
Yeah, you are version.
Guys, can you let them in?
Not necessarily. What did I say about a decimal? It just means you have to take your answer and
Oh, move the.
You gotta round it.
you have to round it. So if you get like 6.2
It's gonna be
teachers,
13.9.
we'll round it up.
No.
If Gemini cares, you know it's serious, okay?
13.
So, what should we round that to? 14.
How'd you get a decimal?
I just typed in 293 divided by 21.
I didn't get a decimal, I got a full number.
293 divided by 21.
I don't know how
I got 13.95 blah blah.
Yeah. Wait, let's.
You know what?
Joe, I'm gonna check.
3.14592.
Oh my god, I totally thought, okay.
You'd be one
Figure it
of
out.
those people that like.
Okay.
Yeah.
Then who else got 14 teachers?
I got 14.
14?
How do you cause that?
Raise your hand if you got 14.
If they got 18, I know what they did because I got
You just round.
13.95.
Yeah, that's right. You're good. Okay, so guys, I need your attention up here. Any questions on how to use a formula to make a prediction?
No.
All you have to do is plug a number in, but you have to figure out if you should plug it in for X or Y. Okay. Okay, last thing. This is a little tricky. Okay? So this involves kind of using, you have to think about
Make some logic.
the problem a little bit. You have to use logic. So the first term I'm putting up there is causation. Okay, causation.
You caused it.
Causation means that if you change one thing, another thing automatically changes. Can anybody think of a situation where you change one thing and it automatically, there's no option, it's automatically going to affect something else?
Christmas lights.
No, on the TV remote, if you put the number, it automatically changes the channel.
So pressing a button will cause the channel to change.
Christmas
Negative numbers.
Okay,
Like
what
being a box of ice cream.
Joe, raise your hand. What about Christmas lights?
If one goes out, they all do.
No, they don't.
Yeah, that's a thing.
It depends.
I had some hanging up in my room in like 4 in the morning.
Gemini is listening to the 12 paint.
It's all about circulation.
So here's another one, Gemini, thinking of like using electricity.
If you cut one of the veins in your neck,
If you use more lights, you will use more electricity. There's a causation there.
I wanted
The more Christmas lights you have, the higher your electric bill will be.
No,
The meter goes.
the more.
I hate when my meter runs out.
I hate when your meters run out when I went to take a shower and it's crazy.
You know, that's a good example. Pay attention and we're done.
Okay, so causation means that if one thing changes, the other thing has to change.
Oh, so it's like the positive and
Wait, hold on.
gives it like
So
like double negative and becomes positive.
what you guys have to understand is the difference between the word causation and correlation. Okay, causation means as one thing changes, another thing has to change. Correlation means that there might be a connection between two things.
Causation, think of like cause and effect. Because of this is gonna happen. It has to happen, it's guaranteed.
So this works one of two ways. If two things have a causation relationship, then they are correlated, but not the other way around. Just because there's a connection or a correlation between two things, it doesn't mean one causes the other. Okay, little confusing with an example. it'll make more sense.
I don't have correlation on my page.
That's okay, you only need to know causation, it's okay.
Okay, so what I want to ask you, I'm going to give you an example. I want you to tell me if it's a correlation, a causation, or both. We'll go through it together.
Hey, you can have both.
Okay, time spent exercising and the number of calories burned. So the first thing is, do you think there's just a correlation? Do you think there's a connection between the time you spend exercising and how many calories you burn?
Yeah. Well, I don't know because it depends on how much effort you put into your exercise.
The more calories you eat.
Yeah, well, maybe.
The calories you burn depends on.
I would say there's probably a correlation. Okay, I would say if you graphed a bunch of data about how long somebody spent exercising and how many calories they burned, you would probably see a trend. You would see a pattern. So tell whether a correlation is likely. Yes, I think there's probably a pattern to that. So a correlation is likely.
Oh my god, there's a really tall kid in the hallway.
He's on a chair.
He's full.
All right, so now the next thing. If there's a correlation, we're going to take it the next step. Is it a causal relationship? What do you think? Do you think if you spend more time exercising, let's just say you're doing the same exercise. Don't say you're switching exercises. You're using a treadmill. If you spend more time on the treadmill, and don't change the speed, don't do anything like that. But if you stay on the treadmill at the same speed for 10 minutes, and then you stay on the same speed for 20 minutes, is it guaranteed you're going to burn more calories? Yes. So staying on the treadmill longer at the same speed, don't slow down, would cause you to burn more calories. So if so, tell whether there is a causal relationship. Yes. This is a causal relationship. Assuming you don't change anything else, you don't change the incline, you don't change the speed, you stay on for 10 minutes and you stay on for 20 minutes, you are going to burn more calories.
Causal means this. We know there's a correlation, yes, but causal means it's very likely. It's almost like guaranteed. The more time you spend doing exercise, the more calories you're going to burn. Pretty good chance.
Okay, the next one. It says the number of banks and the population of a city. Do you think that if you were to graph populations of cities and how many banks in that city, do you think there would be a trend?
Yeah.
Of course.
I would say that in general, probably the bigger cities have more banks, right? So I would say a correlation is likely. Okay, now causal. If you build more banks, if you put more banks in a city, will that automatically cause the population to go up?
No.
No. That is not causal. If you build more banks, it doesn't automatically make the population bigger.
Guys, the first thing listed has to affect the second thing. Almost has to guarantee the second thing to happen.
I just got it, guys.
Okay, so does everybody see that? Building more banks doesn't automatically make a city have more people. It's like building more schools doesn't automatically
mean there's more kids.
Means there are more students. Maybe there's probably a trend with how many students and how many schools.
Like as soon as you did B, that's when I understood the whole thing.
That's usually what makes sense, yeah. Okay, does everybody have that?
Yeah, I say yes.
Okay, first thing, it says the amount of time spent talking on a cell phone and the amount of remaining battery life.
Not necessarily anymore because when I use my cell phone, I can click the power
Yeah, but
button.
it is likely.
Okay.
It does stuff like that.
All cell phones might not have that.
Yeah.
Especially next one.
Yeah, my morning Nick has a flip
No,
phone. It's a little slide up. He's like,
Okay, what do you guys think?
Actually $200.
Is there, do you think there's a connection between time spent talking and the amount of battery life left?
Yes.
I would say there's probably there's a trend there.
Mine was one.
Right? So there's a correlation.
It's a SE.
my phone was an iPhone 11.
Dude, this is like the iPhone like
Now.
1960.
The next question is this causal?
Yes. I see.
Will talking on the phone more, don't changing any settings, if you just leave the phone the way it is and you talk longer, will the battery go down?
I said
Yes.
yes.
That's causal. Yeah.
I said yes.
It's like the treadmill. You can't change the incline. You can't turn on a new setting to save power. Leave it the way it is.
But one time, no,
I told him how to write.
Okay, guys, here's one more I want you to think about. What if I said the color pen that I use to grade your test
Red.
and
no,
the weather outside?
no.
No,
You
no
think-
casual. It's not.
Do you think there's a correlation? No, that kind of thing, that doesn't even have a correlation. And it doesn't even make sense.
So confused.
And if I change the color of my pen, does it change the weather?
No.
No. So it's not a correlation. And if it's not a correlation, it's not causal. Yeah.
Can you stop standing there, please? It's really scary.
Oh my God!
It's monkey!
So
Guys, listen up, this is very important.
okay, guys, you have a choice. Either choice involves something over the weekend, right?
Wait, does it run the majority this weekend?
Yes, majority rules. Listen.
Before I give you both choice, I want you to read everything before you say.
No one shout anything out.
And guys, listen, once we go through it, I'm gonna give you a little piece of paper, you can write your choice on there. And then kind of fold it up, and I'll come around and take it from you. So
Alright, shh. Everyone be quiet, please. Thank you.
Okay, so option one. Option one is a take, but don't say anything till you read all the things
yeah,
I would say.
you're gonna vote on a piece of paper anyways.
Take home test on what we learned this week. You have tonight, you have tomorrow, you have Sunday, and I think I changed this on Google Classroom.
Yeah, 10.
10. It would be due by 10 a.m. We have all weekend.
Option 10, please.
Okay? If you turn it in
Guys, you
late,
can drop it off to Mr. Hager or I, doesn't matter.
I don't know what to do.
Just slip it under the door.
no, don't slip it under the door.
Give it to
He's
one.
gonna step on it.
Because things that go under my door disappear.
Yes.
So you have to give it to me or Mr. Roy directly. Don't just put it under the door and hope that somebody doesn't go away.
How about we give it to Santa?
If your test is late,
Grandpa, that's
Okay.
monkey.
Josiah, if your test is late, it would be a 0. Don't turn it in at 10:05. Don't turn it in on Tuesday.
10-1.
Nope, 10
What's
o'clock.
10?
Like, I have a serious question. Like, does it count when you pass out like 10, 15 seconds in here?
No, it's got to be in my hands by 10.
Okay.
10 o'clock.
Exaggeration.
So not even 10. Why did it's in at 10?
It's 10 to 0.
Yes, I'm in my 10. When you come in the first thing in the morning on Monday, give it to one of us. So
Can
that's-
I just take pictures?
If you are absent, okay, it is still due. If you're absent, you have to take a picture. You've got a nice fancy phone. You could take a picture of it and email it.
Hello.
You could scan it, take a picture of it. You've got to email it to me by
I'm 10.
10.
Here's my tax information, guys.
If you do the take home, you will not have any of this material on the next test.
Remember, vacation and shop. You might forget this week's material.
You might forget it.
Now you can point.
If you do the take home, there will be no other homework this weekend. Just that. That's option one.
You guys are cruel.
Why you always lie?
Ready for option 2?
Not really.
You're not?
I am.
Option 2 is just a regular homework assignment,
I want option 2.
just like
I
normal.
haven't even read the. No!
Okay.
Just think about it this way.
It would be due on Monday
Door number 2.
after vacation. So Monday after vacation is the 26th.
No, don't do that door, there's a shoe in there.
If you do option 2,
Guys, listen.
there is no take-home test. No take-home test. If you choose that option, then this material will be on the next test. And like Valerie said, it is quite a while till the next test.
3 weeks, just telling you all, 3 weeks.
And
Now we said we won't see you guys again until after break.
Everybody's got a light bulb up there.
Okay, so before you vote, I want to give you one more
Guys, listen up.
piece of
Max,
information.
do me a favor, sit down, okay? Let's get the big one.
This term is a little shorter. We only have 4 academic weeks, okay? 1 week is already gone. The last week of the term is short. I think it's Good Friday. And there's sophomores have MCAS, which means we probably won't have class 1 or 2 days that last week.
So it'll be like it'll only be a 3-day week for class.
Could be 2 or 3.
Aw, man.
So what that means is we might not get a test in that week. I'm not sure. So if we don't do a take home and we don't do a test the last week, that leaves you with 2 tests for the whole term. Unless we give a test on an MCAS week, that would give you 3.
Let's do a take home.
Yeah, let's do the take home because also to get on.
No!
Okay, so you guys get to decide with a secret ballot. You have 5 minutes.
Alright, we need to vote.
Quickly vote.